Diffusion by Arpita, Tim, and Zoe. In this experiment, we are investigating the different effects of having a larger sized particles in the solution of water. In class, we learned about diffusion. Underneath the microscope, we are able to analyze and record the movement of multiple beads in the trials. We hypothesized that the larger the size of beads in the water solution will have a lower average rate of diffusion compared to those who are smaller in size. Once uploaded to Tracker, we are able to analyze the different velocities of the individual beads.
Our experiment was designed to compare the difference in rate of diffusion between resin beads of two different sizes, 1.5 micrometers and 5 micrometers. We decided to let both sizes of beads diffuse in the same video because the probability of them interacting was low, and we would be able to stay consistent with the time frames we wanted to gather data from. The first time frame we gathered data from was 30 seconds to 50 seconds. We decided to start 30 seconds into the video because it took that long for both sizes of resin beads to come into focus. The second frame we gathered data from was 130 seconds to 150 seconds. We decided to gather data from this time frame because we wanted to see how the velocities of each particle compared at a point in the video in which they definitely had time to settle. When collecting data, we found the velocity at different points in time of 5 large resin beads from 30 seconds to 50 seconds, 5 small beads from 30 seconds to 50 seconds, 5 large beads from 130 seconds to 150 seconds, and 5 small beads from 130 seconds to 150 seconds. After inputting these velocities into Excel, we calculated the average velocity of each bead in each time frame. Then we found an average velocity of each size bead, 1.5 micrometers and 5 micrometers, for each time frame, 30 seconds to 50 seconds and 130 seconds to 150 seconds. We found that the larger resin beads diffused at a slower rate than the smaller resin beads. One of the biggest flaws that our experimental design presented was within our use of the Tracker software. We used 5 different beads for each size and time frame, and the time frames were consistent. However, many beads went in and out of focus, and it was difficult to find beads that moved consistently with one another. Also, there was a small chance that the different size beads would collide with one another. However, we tried to gather data from beads that didn't interact with beads of the other size.
When we modeled our data, we graphed average velocity of the particles at the two time frames in micrometers per second versus time in seconds. When we did this, we discovered that the smaller beads had a less negative slope than the larger beads. As the slope of the line would correlate to acceleration, this means that the larger molecules slow down faster than the smaller molecules. This correlates with the known equation for the rate of diffusion, k times the square root of T over m, where k equals Coulomb's number, T equals time, and m equals mass. In class, we had previously used the GlowScript app on our computers in order to electronically model diffusion. This GlowScript app, however, was not overly accurate. To begin with, GlowScript does not take gravity into account. The beads all bounce randomly around, never settling towards the bottom of the container. Second, GlowScript particles are completely elastic, which cannot occur in reality as energy is lost through heat and sound to the surroundings.
In conclusion, the resin beads that are larger in size had a lower average rate of diffusion, concluding that our hypothesis was correct. The larger the amount of collision with water molecules, the slower the rate of diffusion. Since the 5 micrometer resin beads are larger, they are more likely to collide with water molecules than those of 1.5 micrometers.